Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Go, where we're using this book, Neural Networks from Scratch in Python. But as you can guess, we writing everything with the Golang. And in the previous video, I started to wire things up for actual training in the loop, and it turns out that I made a mistake somewhere. So what I'm going to do, and I tried to understand it, quickly from the scratch, but I mean, I wasn't able to do this quickly. So what I'm going to do, I'm going to debug. I think most of this video will be debugging things. I have a couple of ideas what went wrong. Another thing that, like in between of the videos, I prepared the Python code from the book, so I can actually check the output of the Python code and check the output of the Go code, because they should be the same. I mean, the logic is the same, but there is definitely some difference I cannot find. And most likely what I will do, I will go like step by step and compare all of the results. For example, the main problem with this, it's not a problem, it's just it will be not that convenient that the layer initialization is random. Where is it? It is random. It uses random weights. Well, it initializes weights as some random array, and that's the first thing. The second thing, that's the dataset that we're supposed to use. It's written with some sort of the randomization too, and that makes the debugging a little bit trickier. What I can do, for example, for the dataset, I've been thinking that I can generate a dataset from the Go, this one, then store it in the file, and then use it in the Python code. So for example, here, instead of calling this spiral data that is implemented inside the neural network from Scratch library, I will just load the same data from, and that will be the first step. I can see maybe it's an issue with the data, and I actually don't have any issues with the actual implementation. If, for example, with this data that I will generate with the Golang, with my code, it works okay. I mean, that the model is still training on the Python code, then it's definitely a problem with my implementation. And in order to do this, I'm going to make model smaller, because right now it's 64 neurons in the layer, and it will be very hard to debug, right? And then I think I will do the same. I will generate some random weights and random weights for the first layer and for the second layer. And I think then I can, with weights, I can, load something. But before we can go into the full this, I actually want to check that yesterday I made a change. I refactored the spiral data, so it returns right now the dance class and the target classes. And maybe I made a mistake here, and how I can do this, I can print, I think I have it somewhere. No, it looks like I don't have it here. But what I can do, I have the scatter class that scatters the data. And what I can do, what I want to do, I want to change, so it will take the mat dense and we will print the data, so we can see that it's still okay. Once we understand that there is no issue with the data, then we can go for the next thing. I'm not even sure that, so we change in this will be mat dense. Don't need this. X, Y. I need to split. Right. Land values. Land values. Land values. It's the first. It's the number of rows. Okay, let's do it like this. We're taking values, dimensions, and is an R here, and then we're doing the same, right? But here it will be at, and it will be I0, right? And here it will be at I1. Then again, instead of we replace it with the R, which is number of rows. That should work, right? So what we're going to do, what it does, it plots the results into the file. I think I don't have this file yet. Okay, I have it. I don't have this file yet, so let's try to use it. What I need, I don't need this one for now. So what I'm taking the values from the data set spiral data and going to the same 100 samples, 3 classes for each one. Then data set scatter data X and Y. Can't use Y variable of type int as the int value. Oh, classes count. All right, so classes count. I mean, got 3 classes. All right, that should work. Okay, points. I mean, from the colors, it looks like 2 classes, and the third one is not good. Okay, right now it's better. So we have 1 spiral, we have the green one, this one, and we have the blue one, which is very close to. Try once again. I mean, they're not distributed pretty much, but okay. So it's not the problem with the data, right? Well, we could, but it's not used. Okay, so what I'm going to do. Well, I mean, I have a couple of ideas of what I can do. Another thing would be to, even with the random, I can create a small. You can create a small model in trying to print every single step and see if it makes sense. Because right now, if I can go into this one. Okay, I don't need it for now. If we run, I mean, it starts actually from smaller accuracy, and if we will print it for example, 100 epochs. But the problem that it's very, very weird. By the way, what I'm printing, this is, I think, this one, no? Loss value. Where's the print right now? Dim, scatter, accuracy. Oh yeah, so we are printing this one just to make accuracy. We have the prediction and predicted classes. I think like this it will be. Yeah, predicted classes and the predictions. And you can see that the predictions are pretty much equally distributed. But if you take a look, for example, here, I mean, the loss is changing, and actually, where is it? Calculate accuracy. So it's at this moment. Okay, let's print predictions, right? So we can see that they are changing, but it's not going to be one specific class. So this is why I'm kind of wondering what is happening here. Okay, for example, let's try to use something smaller. So instead we'll have the 5 and 5 here, right? Will it train? Not that good. I mean, it's changing. So the lost value changes very, very slowly, but it's changes. And if I will try to do the same, how many epochs we have? Like this, but if I change it here, I think I will have no changes. It's really interesting how faster it went through. Or maybe I didn't save just. No, probably kind of the same. It's not this one. This one. Oh, wait. This one. Okay. Damn it! There is no change at all. Okay, so there is definitely an issue. How I can debug it? That's a good question. I mean, maybe I should take a look at the data itself. Just yeah, but I mean, it it looks like but maybe there is something X. Okay, and let's take a look at the data here. Where is it? Print X. Interesting that I have 0 at some point. -0, maybe the number is very, very small. Probably that's the... Oh yeah, 0 itself. So I would say that the data is, well, at least on the first glance, is more or less the same. How I can... Okay, what I can do, I can... The first thing, as I said, I can print it into the file and then load it into the Python code. That will give me an answer if it's an issue with the data itself. Because if suddenly on the data generated in the Go Python version is not working, then there is something wrong with the data. It should not be, but I want to debug everything, so it's because the data is the main source. Well, not the main source, the data is the first step that we're doing. And if it will at some point, it will be broken, then there is no point to go further. How we can do, and it's actually interesting for me how, well, the first thing, what I can do, I actually can take the data from the math, and it will be raw matrix data, right? It will be just a float 64. Then what I can do, I can create a string, right? Var is the string, like this. No, just I think it's string. I never work with strings in Go. What we can do? We can do for I think value on in range data underscore is there equals, can I do like this? Or maybe there is a pen. Go string. What I can do with the string? Okay, maybe this one. No. Oh, maybe guides string. Yes. String type represents the set of string values. A string value is a possibly empty sequence of bytes. The number of bytes is called the length of the string. How I can add things. Declared string type is a string, it is a defined type. The length of the string S can be discovered using the built-in function len. The len is a compile time constant if a string is constant. A string's bytes can be accessed by the... Okay. It is illegal to take the address of such an element if S there is. Okay. Can I do something like this? Master value? Can common function float to float to I didn't know. Okay. Okay. Is the one float? Append float appends the string form of the floating number f as generated to destination and returns the extended buffer. So is there con append float? Is there float value? Not enough arguments. Okay, and it's like this, right? Not enough arguments in the call. Empty bytes. What is empty bytes? Okay. Yeah, it was actually an easy way just with using the sprintf. Probably it's not the best way, but I really don't care currently. But what does it mean? It means that we have a string. And actually, maybe I don't even need to. Is it really big? Maybe I'll just do. No. I mean, data set by. Well. I think I can do this just values equal to values 3 equal to. Let me copy this. Can I then copy it from data set from import value string? Okay, so it should have the value. Then dev generate. It does not generate parse data, and it will return. So star items equals to value string data set. Dev data. I'm writing some shitty code right now, but from data set import data. Right? Yes. So data split like this. No. Okay. Then what we're going to do, we have the... I mean, we actually should be able to return in P array from insert items. Let's take a look. And I mean, XX equals to parse data, right? Okay, and then we print XX. Okay, so we have some values, and well, like this. X. I think they have different shapes. This is one. Yes, and I need to reshape it into two-dimensional array. So reshape and reshape. NumPy reshape. Given a new shape to an array without changing that array to be reshaped. New shape int or tuple. So I want to have 300 by 2, right? Okay. That looks like our data. Okay, what it means then? Then it means we can, well, first I can test the previous, like the version with the hidden layers, with one within hidden layer of the 64 neurons. I mean, yes, I will take the classes from here because they kind of the same. I'm only changing the... And should be like this. So, okay, so it works. Right now I have this data set, and what I can do, I can create the same here. I can do the same here, but it will be, mock spiral, right? It will be mock spiral. It's still the package dataset, right? Inside. Oh, okay, then we have values 3. Oh. I'm thinking, but it's actually should be values as float 60 as array of float 64 and equals to this. right? Okay, so let's do this. We have the function mock spiral data that takes nothing but returns math dense. Yes, so we have values. Oh, it's called raw values, which is equal to float 64 and has these tons of them. Yes. And then we are reshaping it. We're creating the result, which is math new dense. We have the 300 by 2 by row values, and then we return result. Let's take a look. Oh, not this one. This one. We have, for example, okay, I'll delete this one. I have the x equals to dataset mock spiral data. Mock spiral data, then fmt print, and then starts math format x. Okay, let's check in if they're the same. Right now we have the same data. What does it mean? It means that I can copy this one. I can copy it here. I will call it XX for consistency. And I will do this. Okay, then I can train. But again, same loss value, same epoch, oh, same accuracy. Okay. I'll close some things that I don't need right now, that maybe need. Next thing that we're going to test is scatter works correctly, railroad don't need mock spiral. Okay, but probably I will need to mock. Well, the next thing I'm actually going to check is the magnitude of the generation of the weights, and what it gives me. Yeah, I will check, then I will do the same. I can generate the weights with the Golang, put it into the Python for 2. So for example, here I have this one and I think this one. So we will have the mocked because Let's take a look where I'm using the rand. I'm using rand to initialize the weights. For the biases, it always 0, right? Spiral data we already mocked. Scatter, we don't need it. Vertical, we're not using right now. I think I don't use this one anymore. Yes, I will delete this one. This one uses the vertical data and I'm not testing it anymore. And same with this one. Right, so let's take a look again. Rand, dense layer, spiral we skip, vertical we skip. So the only place that I still have the randomization is the actual weights, and this is the line. Let's take a look again how it's created here. And it has number of inputs, number of neurons, zeros. Okay, so let's take a look. Main, okay. Okay, let's take a look at the init states. Okay, this one is clear for me. I will put this one here just for consistency. Okay, so let's start from dense one weights. Okay, we're going here. Where is it? Okay, 5 again and 5. So we print in weights. Yes, and the weights look something like this. They're very small. And okay, here how I can print. I actually have. Let's me. Okay. Okay, that's not dense one weights and okay, they're actually pretty. I mean, let's take a look at the second one. Where is it? Stop. I mean, in the Go, they are much smaller, but not all of them. I mean, again, the epoch, the loss is changing. Okay, let's. I want to find the number of the neurons here that is makes a significant difference in the loss. Okay, 10 and okay, can I find all of this? 10 GC. No. 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 Yes. Yes. But I still... But it still doesn't make a difference. Yes? By the way, I need to return this. Otherwise it's hard to see. This one... No. Interesting, what's the first value? Actually, let's take a look. And loss. Oh, so I'm checking the recording time. Okay, so for today, I think I have around 10 minutes left for the recording, and then I need to go. What I'm going to do, I need to prepare these. Well, this is the data. I need to create dev mock dense one weight, and I will return. Then I need to do the same for the second one. We will copy. We'll copy values from here. How I'm going to do? I think I don't have the code. Okay, func dump dense. Let's make it like this. Values math dense, and yeah, I will just print it. So what I'm going to do, I have the str simple string, then I'm going for, I don't need an index, I need a value in values. Equals to range math. No. Values dot row. This one. What we're going to take? Str equals string plus fmts print f, right? So we define in the format as %float comma, and then the value. Expected type found. Okay, and then we doing this print len string, right? What we're doing right now, we're doing dump dense, which is the dense one weights, the first one, and we dump in the second one. So wish mark. Ooh. Nice. Okay, so we have the, and I will return the numpy array. So import numpy as an p already. Then I'm taking the first values. Where is them? I think this one. Right? Then we return in np.array from this. Then reshape. And what do we reshaping? We're reshaping into 2 rows. No, 2 rows and 10 neurons, right? Then we take in the second one, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we take in the second one, and we return in the, again, np array from the list of these values, right? And then we reshape it into 10 by 3. What it means? It means that I can right now dense 1, I can take weights, and I can mock. No. And I can mock this, right? Then I can do the same for the second one. The top one for the second one, 00086. This one, for example, 44, okay. Dense 2 weights the same. Dense 1 weights, for example, the last one is 0091. Where is it? 0091, and the first one is, oh, not that second one, 008542. And if I will, okay, run it once again for the clean, just to be sure. Oh, right, and I need to do the same here. Right, so we dump the dances, which I don't need right now, but I need to have to do mock weights and to do mock weights. But I think I will, yeah, we'll start the next video from this, but I want to test what was 0001. It's raining, right? So the loss is changing, the values are mocked, yes. So the values are mocked. Where is it? Dataset, mock spiral. To be honest, I will just put here. So I have the func mock dense 1, and that will return methods. So we'll have the same values equals to load 64 with some and then copying this and posting here, but in this case, okay, let's call it values. It's, yes, 2 rows by 10. Okay, then we have the second, and the only difference is we have 10 by 3, and now we need to change this one inside. Okay, what it means? Means I have dense 1 weights equal to dataset mock dense 1. Okay, let's try. And for example, second row here, the last before the second row, it's the same. And here, for example, this one is okay. Let me try once again. Okay. And I have the same loss and the same accuracy. What it means? I can return number of epochs, and if we take a look again here, there is no change in the loss and the accuracy, and here we have. So, what it means? It means that in the next video, I will go and test all of these things and actually, well, with the prepared data right now, it will be very easy to spot the problem, because I will just, go forward, print the result, go forward, print the result, go forward, print the result. If there is no problem with the forward pass, which might be actually the thing, because I have the same loss value in the accuracy, so it might be that there is no problem in the forward path, although, we'll see. And then I will do the same for the backward path, and I will just see the result. Once I found there is a difference, I will dive and understand what is the problem. So, but for now, thank you for watching, and I see you in the next video. Bye bye.